In this lesson, a one-turn battle becomes a complete and trustworthy game loop. Choosing friendly nudge repeatedly reaches a normal defeat. Rest and retry creates a genuinely fresh attempt with full resolve, a cleared log, and the opponent decision cycle reset. Choosing bramble bounce reaches victory. Only then does the battle return a victory result to the world, where the party is healed at one controlled boundary. This is episode 10 of Glimmergrove, and it is also a standalone Godot lesson about terminal states, invariants, deterministic loops, retry ownership, signals, and regression tests. The starting and finished projects are linked below. Our promise is narrow but complete. A battle accepts one legal choice at a time, resolves repeated turns, ends in exactly one victory or defeat, offers retry only after defeat, and returns one explicit result to the world. We are not granting rewards or waymarks yet. We are not adding random opponent intelligence, status effects, or battle animation. Those are separate responsibilities. Episode 11 can award progress safely because episode 10 first proves what a true victory is. Series viewers should begin from the Chapter 9 checkpoint named Glimmergrove CH091 turn. Standalone viewers can download the completed Chapter 10 project and rebuild this lesson in a separate copy. Use Godot 4.7.1 stable, the compatibility renderer, and an 1150 2x648 viewport if you want the same paths and test values. The state pattern works in other projects, but do not paste these paths into a different architecture without adapting them. Close Godot before copying the project. In File Explorer, duplicate your Chapter 9 folder. Rename the new folder glimmergrove_ch10_complete_battle. Open project.godot from that copy. Leave Chapter 9 untouched. A checkpoint is not busy work. It gives every new failure a clear starting point and lets you compare the old one-turn contract with the new complete loop. Run the copied project before editing. Choose a starter. Speak to Rook and begin the exhibition. One move should resolve exactly one ordered turn. Both resolve bars should update, the move button should lock, and return should become the only valid action. If that baseline fails, restore Chapter 9 now. We want every error in this episode to come from the loop we are adding, not from an older scene or an accidental partial copy. We need 3 terms. A terminal phase is a state with no legal battle action after it, such as won or lost. An invariant is a rule that must remain true through every transition. Our key invariant is simple. Only player input may accept a move. An attempt is one complete battle from fresh starting resolve to one terminal result. A retry begins a new attempt. It does not rewind a few labels. Draw this transition before opening the script. Player input accepts one choice and moves to resolving. Resolving applies ordered actions. If the opponent reaches 0 resolve, the next phase is won. Otherwise, if the player reaches 0, the next phase is lost. If both are still standing, increment the turn and return to player input. Won and lost have no arrow back to resolving. Retry creates a new controller attempt instead of mutating a terminal one. Never decide that a battle is over by reading a label. Text can change for localization, accessibility, or visual redesign. A hidden button can still receive a stale signal. The controller phase is the authoritative state. The screen reads that state and presents it. This direction matters. Rules create text. Text never creates rules. The same principle applies to quest labels, shop totals, dialogue choices, and multiplayer status panels. Open script/battle/battle_controller.gd in the phase enum. Remove turn complete and add won and lost after resolving. Ready still means no valid battle is active. Player input still means one move may be chosen. Resolving still means rules are applying actions. Won and lost are terminal. Save now and let Godot report every old turn complete reference. Those errors are a useful checklist of places whose contract must change. Keep state changed for presentation snapshots, then add a finish signal carrying a victory boolean and a player-facing message. State changed answers What should the battle screen display now? Finished answers. What terminal event just occurred? Separating those meanings keeps the screen from guessing whether a snapshot deserves a one-time reaction. Signals communicate facts. They do not transfer ownership of the rules. At the top of choose move, keep the existing phase guard. If phase is not player input, return false before changing health, logs, or turn count. Keep the negative and out of range index checks. Keep the empty opponent move check. This single doorway protects resolving, won and lost from double clicks and stale callbacks. Disabling a button improves the interface. Rejecting illegal input in the controller protects the game. Replace the opponent's fixed index 0 with a deterministic cycle. Opponent index equals turn count modulo, the number of opponent moves. Modulo means remainder after division. With 2 moves, turn 0 gives remainder 0. Turn 1 gives remainder 1, turn 2 wraps to 0, and the pattern repeats. This is predictable enough to calculate and test, while proving the opponent can make more than one author choice. Randomness can come later behind the same decision boundary. Do not rewrite the speed and damage logic from episode 9. Compare speed once. Apply the faster creature's move. Before the slower creature answers, check whether it is defeated. This prevents a creature at 0 resolve from taking an impossible action. A complete loop should reuse a trusted one-turn rule, not duplicate it in a while loop or calculate damage inside the screen. After the legal actions finish, increment the turn count once. 1 turn means 1 player choice plus the opponent response that was allowed to occur. Do not increment after each creature acts. Do not increment before selecting the opponent move, because the current turn count chooses the current opponent index. This ordering gives the sequence 0, 1, 0, 1 and makes the log and tests agree on what turn means. Now add one mutually exclusive decision. If the opponent is defeated, set phase to 1. Else if the player is defeated, set phase to lost. Else return to player input. Use else if, not 2 separate if statements. Only 1 terminal outcome may be selected. Our action order guard prevents both creatures from falling in this rule set, but a single chain still documents the invariant and survives later effects more clearly. For victory or defeat, first set the phase and append the final log sentence. Next, emit the state snapshot so the screen paints the terminal health, log, and disabled controls. Then emit finished once so the screen reveals the correct result actions. This order avoids a brief interface where retry appears beside stale health. It also gives every finished listener a controller whose terminal state is already complete. In the non-terminal branch, set phase back to player input and emit the next snapshot. That is the only transition that permits another move. Choose move then returns true because one legal request was accepted, regardless of whether it ended the battle. The Boolean reports acceptance, not victory. Keeping those meanings separate prevents callers from treating every successful button press as a one encounter. Save battle_controller.gd. In Go's script workspace, confirm there are no red parser markers and no old turn complete references. Use search in files if necessary. Do not continue while the editor reports an invalid enum name or an untyped signal mismatch. Parser errors often cascade, so fix the first reported line, save, and check again before touching later lines. Open script/battle_screen.gd. The screen needs enough information to create a fresh attempt, the active companion and the battle definition. Store those references when present is called. Add last_victory as a boolean for the eventual world result. The screen may own this presentation flow, but it must not calculate damage, choose winners, or heal the party. In ready, connect retry press to start round exactly once, beside the existing move and return connections. Do not reconnect retry every time a battle opens. Repeated connections cause one click to launch multiple attempts and are especially confusing because the final screen may look correct. Scene lifetime controls connect once. Attempt lifetime controllers are created separately. Create start round as the single function that begins an attempt. Reset last victory. Hide retry and return. Create a new battle controller. Connect state change to refresh and finish to battle finished. Only after both connections exist, call start with the stored companion and battle data. A new controller resets phase, turn count, opponent instance, and log together. Retry is construction, not repair. The connection order is not cosmetic. Controller start emits the initial player input snapshot. If you call start before connecting state changed, the first update disappears. The controller accepts moves internally while the screen can remain disabled or stale. Connect listeners first, then invoke the operation that emits. This pattern appears throughout Godot when a newly created object immediately reports state. In battle finished, store the victory value. Show retry only when victory is false. Show return for either terminal result. If retry is visible, give it keyboard focus. Otherwise, focus return. A player who loses receives a clear recovery action. A player who wins cannot farm the same exhibition by pressing a misleading retry button. Focus is part of correctness for keyboard and controller users, not an optional polish pass. In refresh, derive move button interactivity from one expression. Phase equals player input. Every other phase disables every move. Do not enable moves because health is above 0 or because retry is hidden. Those are indirect clues. One authoritative phase keeps presentation synchronized with the controller and makes a terminal second click test meaningful. Expend exit requested so it carries victory, battle id, and reward flag. When return is pressed, emit last victory plus the identifiers authored on the battle definition. This does not grant a reward. It preserves result identity, so episode 11 can decide whether this particular victory earns this particular progression flag. A generic close signal would force main to remember hidden context or guess which battle just ended. Open script/state/game_session.gd add heal party. Loop through the runtime party. Call heal full on each valid companion. Then emit state changed once. Healing belongs to journey state because those runtime companions persist outside the battle screen. The battle controller may heal its active participant when a new attempt starts, but the world return policy belongs at the session boundary. In main.gd, update on battle exit to accept the 3 signal values. Hide the battle screen, call game session heal party, restore the world controls and HUD. Then refresh the HUD. The order matters. If you refresh before healing, the village can briefly display 0 resolve. Keep the battle id and reward flag parameters even though this chapter does not spend them. They are the tested seam for episode 11. Before running the game, calculate the intended loss. Bramblebud starts at 34 resolve. Bell Wisp's alternating moves deal 9, 8, 9, then 8. So Bramblebud reaches 25, 17, 8, then 0. Friendly Nudge deals 9 each time. So Bell Wisp reaches 19, 10, then 1 and remains standing when Bramblebud falls. The 4th player action is skipped because Bell Wisp is faster and defeats Bramblebud first. That skipped action is an important rule check. Now calculate the win. Bramble Bounce deals 11. Bell Wisp reaches 17 after turn 1, 6 after turn 2, and 0 after the player action on turn 3. Bramblebud receives 9, then 8, and remains at 17 because Bell Wisp cannot answer after reaching 0. These exact numbers prove speed order, damage, alternating opponent moves, defeat skipping, and the terminal phase together. In the file system doc, right-click tests. Choose create new, then script. Name it validate_complete_battle.gd and choose the empty template. This focus test should load the real content. Start an attempt. Drive the loss route. Reject input after loss. Heal and retry. Drive the win route. Reject input after victory. And verify the return state scene. It tests rules directly without pretending to replace the human interface check. In the first half, repeatedly choose move index 0 while phase remains player input. Add a safety counter so a broken loop cannot run forever. Assert that phase becomes lost. Player resolve is 0. Opponent resolve is 1, and another choose move call returns false. This final assertion proves the terminal invariant at the rule boundary, even if a future screen accidentally leaves a button enabled. For retry, create a fresh controller through the same start path used by the screen. Assert full player and opponent resolve, turn count 0, an empty battle log, and player input phase. Do not only assert that the bars look full. A leftover turn count would shift the opponent move cycle. A leftover log would leak the previous story. A reused terminal controller could reject the first new click. In the final half, repeatedly choose move index 1 while player input remains active. Assert 1, opponent resolve 0, player resolve 17, and rejection of another move. Also assert that the finish signal reports victory once. A visual victory sentence alone would not prove that main receives the correct result or that no extra action can mutate the completed battle. Close the running game. Open PowerShell. Put your real Godot console executable and project folder into the 2 variables shown. Run Godot headless with path set to your Chapter 10 project and script set to res://test/validate_complete_battle.gd. A passing run prints that defeat, retry, healing, repeated turns, victory, and terminal guards work. If the exit code is non-zero, stop and fix the first reported assertion. Run the broader content validator and first, companion validator 2. The complete battle test can pass while an unrelated resource path is missing or another starter has invalid data. Testing should widen from the changed rule to the surrounding content contract. All 3 checks must pass before the play check. Automated tests are fast at exact numbers. They cannot judge focus, legibility, or whether the result feels understandable. Run the project and enter Rook's exhibition. Choose friendly nudge 4 times. Confirm Bell Wisp's moves alternate. Bramblebud reaches 0. Bell Wisp remains at 1. Move buttons disable. Rest and retry appears. Return remains available. And keyboard focus lands on retry. Press a move key or click the old move area again. Nothing should change. That deliberate invalid action is part of the play check. Press rest and retry. Both creatures must return to full resolve. The log must be empty. The first opponent choice must again be bell chime, proving the turn counter reset to 0. Result buttons must disappear. Move buttons must enable. And focus must return to the first move. If only health resets, you do not create a fresh attempt. You patch presentation around stale state. Choose Bramble Bounce 3 times. Bell Wisp should reach 0 while Bramblebud remains at 17. The log should end with, your first bond held steady. Retry must remain hidden. Return must be visible and focused. Try one more move input. The numbers must not change. Then press return and confirm the village reappears with the party healed. No waymark should be granted yet. That is episode 11's responsibility. If the battle never ends, inspect the phase assignment after actions. Terminal checks must run after damage and after the turn increment. Confirm is defeated reads the same current health field that take damage changes. If an automated loop reaches its safety limit, do not increase the limit. Print the snapshot after each accepted move and find the first value that differs from the hand calculation. If one retry click appears to start twice, search for every retry button pressed connection. It should exist once in ready, not in present. Refresh, battle finished, or start round. If the initial screen stays stale after retry, confirm state change is connected before controller start. If the opponent opens with the wrong move, confirm retry created a new controller and reset turn count. If moves remain active after a terminal result, make refresh disable them whenever phase is not player input. If retry appears after victory, assign its visibility directly from not victory. If controller logic works but keyboard users become stranded, call grab focus after visibility changes. Never fix these problems with timed delays. The interface should be a direct projection of authoritative state. If your project still differs, download Glimmergrove CH10 complete battle.zip from the description. It's SH250, 6 begins 9CCF5AE, and the full value is shown on screen and below. Extract it beside your work, never over it. Compare one file at a time, starting with Battle Controller, then BattleScreen, Game Session, and Main. A recovery checkpoint is evidence and a clean restart, not a reason to paste unknown code blindly. The reusable lesson is larger than combat. Give the rule owner explicit phases. Accept commands only in legal phases. Emit detached snapshots for presentation. Emit one-time event signals for terminal facts. Create a fresh attempt instead of repairing terminal state. Return result identity across system boundaries. Then test both expected transitions and forbidden transitions. This pattern scales to crafting, dialogue, quests, card rounds, puzzles, and authoritative multiplayer match flow. Episode 10 is complete when repeated turns are deterministic. Victory and defeat are mutually exclusive terminal phases. Retry resets every attempt, own value. Terminal input is rejected. The screen presents honest actions and focus. Main receives battle identity. World, return healing occurs before the HUD refresh, and all three validators pass. Do not move forward with a battle that merely displays the right sentence. In Episode 11, we'll consume the results seam we built today. A true victory from the correct battle will grant one waymark, update the objective, and survive save and load. A loss will grant nothing. Repeating an already completed victory will not duplicate progress. If this lesson helped, download the checkpoints, run the test yourself, and continue with Episode 11. Build rules you can explain, states you can inspect, and progress you can prove.